Hi everyone, my name is Nikhil. So in this video, we're gonna be creating a system design of a full-fledged and scalable notification system, right? So in this lecture, you will learn a lot of new things that how does a notification system works, what are the providers for that, how we gonna manage the scalability, how we gonna manage the message queues. Yes, we'll be having the message queues as well within that with using the Kafka. There will be a lot of things that you can learn inside this video, right? So we're gonna start from very basic design with the pencil like this. We'll be having a simple service of a server and all the things. Then we're gonna be moving on to the message queues using the Apache Kafka. We will give you an overview as well that how does the Kafka works, what are the components, and then you will get to know about a lot of things regarding that. And then in the end, finally, we'll be having the complete system design with that after that. So this will be the final design where we have a lot of components. We'll have all step-by-step things, the data format as well with this system design tutorial. So let's not waste time. Let's directly move on into the lecture. And don't forget to like and subscribe to this video. Hi everyone, welcome to this lecture. This lecture would be very much interesting because we're gonna design the notification system completely from scratch. So you will learn how does a working notification system will look like, how does the data flow will work, how does the communication and their channels will work. We'll be creating complete system design and architecture for a notification system, and we'll be taking example of a LinkedIn app, an application like a LinkedIn, because LinkedIn has a lot of components that could be for the connections, that could be for the post, their likes, their comments, right? And there could be a lot of things as well apart from that, like we have the messaging and most importantly the jobs of the LinkedIn, right? So there might be a lot of communication channels and they provide notifications to multiple users regarding that, right? So before just moving on directly into the designing part, we first have to understand what are the channels of the notification, how does the notification will look like, and what are the types of the notifications. So notifications can work in a lot of ways. Notification could be anything. Suppose we take an example of the mobile notifications, right? Suppose you order something from any e-commerce store, you receive the delivery updates, right? You receive a lot of updates like the payments from the bank and a lot of things. These are the mobile push notifications, right? And there are two channels for that. One is the APN, which is the Apple Push Notification Service. Second thing is the FCM, which is the Firebase Cloud Messaging. So these two are the mobile channels which are available. This for the iOS, this for the Android, right? There are two channels, APN and FCM for the iOS and Android. Another thing is we have another channel for the email. For the email, you can use any channel like we have the SES, which is by the Amazon simple email service, or you can use the SendGrid, which is very much popular for that. So this is for the email channel, right? And there is something you can use that is a Twilio. Twilio is for the SMS, right? The SMS is for the Twilio. And then apart from that, there are multiple channels. There are other multiple channels as well. One is that no one talks about is the in-app, right? There is in-app notifications as well. In-app means suppose you use the LinkedIn application currently. Suppose we take an example completely for the LinkedIn. For the LinkedIn, we see the messaging as well. So if someone contacted you, if someone sent you a post, if someone liked your comment, pushed a new like or something with that, so you receive the in-app notification as well. That is provided to you by the real-time like libraries that could be like a real-time protocols that could be the WebSockets, right? That is for the WebSocket integration for that. So they have the integrations. Apart from that, the final could be we have the web push as well, right? On the Windows as well, you sometimes receive the notifications from channels and from that. So you might receive that from the Google Chrome or from any browser that you subscribe from the notifications. So there are multiple libraries available for the web push as well. And directly on the web, there is a notification push directly, which is available, right? So these are the type of notifications. Now we have to design the system that how a end user will receive a notification from something. Suppose we have four services: connections, comments, messaging, and the jobs. From these four services, let's first design something that you will receive the notification from the system, right? So from designing that, you have to understand there might be something which is these services, right? That could be the service 1, service 2, service 3, service 4, right? They might be the standalone services, again the microservices, right? They are the particular independent microservices. Now what happens is each service communicates to something which is a big beautiful notification server, right? That is a notification server. So this server will be able to handle all of the notification related tasks. That could be the processing the notification. That could be another thing, that could be storing in DB or cache that record, right? It could be used for the caching. Third thing, it will be responsible for sending and delivery, right? So there are three main tasks or three main components of this notification server that will handle that. And then finally there will be the channels for that, again which we discussed just a moment ago. APN, that could be the APN. Second thing would be we have the FCM. Third thing could be we have the SES, which is simple email service. Then we have the Twilio. Then we have the WebSockets integration, and then we have the web, right? So they communicate with the appropriate service providers from that. So this is the job of the notification server, to communicate with that. And then finally the end devices, right? The end devices will receive the notification on their system, right? And on the mobile as well, you receive the notification with that, something with that, right? So this is a phase 1 diagram. Like, the services communicate with the system very simply, and then it processes all the notifications to these services, to these third party services, and they have the job to process the notifications for that, right? So this diagram also looks similar to what happens in the real world, right? Let's name this diagram as the SD, which is 1, which is the first version. That could be the V1 of the notification system. So V1 is also good, right? Multiple services communicate with the main server, right? Let's keep a different pen for explaining. Multiple services have one server of the notification. This is one single server, right? Then they communicate to all other channels like the APN, FCM, SES, Twilio, WebSocket, and the web. Notification server has the jobs of processing, storing, and for sending and delivery, right? These three are the main tasks. And then the end users receives the notifications on their devices. Very good. Now this design is okay, but you have to understand there are some flaws for that, because every system is not perfect. What are the problems with that? Problems. First problem in the notification system is, like, there is SPOF. It is not SPOF proof. Now you will ask me, what is a SPOF? SPOF is something which is a single point of failure, right? There's a single point of failure. So let's say the notification system goes down. Suppose there was a security breach, there was an attack. So now this system is down. It is not working. So now all the notifications will go trash. They won't even receive that. All of the requests will be timed out. You won't be receiving any notification from any channel, right? There's single point of failure. Second thing, the scaling, right? Now the notification system has a lot of tasks. We have the processing, right? We have processing the notification. We have storing inside the DB. We have the delivery. So scaling issues might be there because this is handling a lot of things, right? Suppose if you don't know, even if you use the symbol DB here, right? Even this is your server and this is a DB, right? This is a DB. So the DB roundup also takes time because you establish a TCP connection and then you have the handshakes for that. Then finally you communicate, you receive, you send a query to that again, and then you have the resulting query for that, right? It can also take time. Suppose you are receiving almost 1k plus request for this, like 1000 plus request, there might be an issue with that, right? So now the final thing inside that, what will be the final thing issue with that? So scaling we have already discussed, like there's no scaling part over there. Final thing could be we can move on, that's performance. This is a monolithic application. This handles again a lot of things like the delivery of the mails, the DB caching, it can communicate to the DB. So every request comes in via the REST or GraphQL, right? To this server, it does a lot of things, and then there are hundreds of requests coming in, thousands of requests coming in. So they might take time, and it might take a lot of time to process each and every notification in detail, right? It could be good for the 1k, but what if you send around 2000 or 3000 requests? The users might have to wait, or also the request can also be timed out, because if it is processing 1k request, so 1k will be waiting, right? 1k request will be waiting for that. They might have the request timeout. So considering these problems, if you have something in mind, you can just let me know, or if you have more problems to discuss about the SD1, let's, you can do a chat, you can open a query. I will just respond to that. Now, moving ahead, what we're gonna do is let's create the second version of that. Let's create the SD, which is 2, which is a V2 of our diagram. Now the V2 again includes the same services because the services cannot be changed. These are the in-app services, right? That could be the service 1, service 2, service 3. We had, I think, 4 services. Yes, we have the service 4. Now these 4 services will move on. Now they have to communicate via something else. Again, now there will be a notification service, right? There will be a notification service. Again, a notification service. Now, but this service can decouple some things from their complete unit, right? One thing it can decouple is the DB, right? Now it can create another services for the DB. It can create another service for the caching as well, right? We have the caching and we have the DB, right? So for every request, a new roundup will be moved on to DB again, but DB roundup is still required because we have to store the notification, right? So there will be the DB roundup, there will be the cache roundup as well. But if you already have inside the cache, there won't be any issue. After that, this will be the API request, right? This will be the API request, but the notification system will itself broken down into multiple things. Now comes something which is a message queues. Now we'll implementing one thing which is a message queue. What is a message queue? So you know that suppose all of the services were communicating through the server, right? So what happens in the normal application? Suppose we have an application without the message queue. So one API request is going to be sent to another service and then they have to respond to that, right? There is a TCP connection again, right? There's a TCP connection because HTTP is built on top of the TCP, right? There's a TCP connection, there's a HTTP request, sending, transmitting the data, receiving the response, right? That could be the response for that. But if there might be if there might be hundreds of API requests coming in, and if there might be even two, three, or there might be six services for that, so each services would be communicating to any other service. So instead, we can use something which is a message queue. Message queue is something. So if we take an example of the message queue, we have the system 1, you have the system 2. Now system 1 will send the API request again. API request is still important. API request to the message queue. But now the message queue won't give the immediate result. Suppose we use to send a notification, but this won't give the exact result that now the notification is sent. This will store that notification in some form of a queue, right? There might be a queue in some form of the queue. It will store the notification inside the queue and then it will just move on. It will send that notification is processing, and do not wait for me because it can take time. So it might send that the notification is processing. That's it. So it means we have something beneficial. It means we have the lesser response time, right? And there is no overload, and we have the no overload again in single server. Now moving ahead with the message queues, we'll take an example that how does that work. So if you have heard something which is a Kafka, nowadays it is being used a lot, right? Kafka is provided to you by the Apache. So they have this Kafka. So what happens in a Kafka or what happens in a message queue is we have one application which is a producer. That is not a film producer again. So this is a producer and there is something which is a consumer, right? The producer moves on and sends something inside a broker. So there is a broker in between that, right? There's a broker in between that. So producer, what it does, it communicates with the broker. It sends the queues to the broker. It will insert the data inside the queue that this notification has to be processed. It will send that inside the queue. Queue will fill up that particular notification box. Then the consumer will pick directly from the queue, right? The queue will be stored inside that. So consumer will pick directly from the queue. Now there is no direct call between the producer and the consumer services. There is no direct call. The producer will just insert inside the queue. Consumer will read from the queue, right? So this is how the messaging or this is how the message queues work. There is no immediate response. There might be some delay, but they are in the real time as well because nowadays Kafka can support around 1 billion requests as well. That's it. Now, this is a very basic overview, but if you want to learn more about the Kafka, because here we might need that, right? We might need that. So what we're going to do here is we'll be using the message queue. Now, what will happen inside that? So what we're going to use is we have the Kafka. Kafka has a lot of components internally. We are not going to discuss each and every component in detail. So I'll create a separate video for the Kafka and the queues for that, Kafka and the messaging queues. But for now, let's keep the focus into designing phase. So for designing that, we need to have some knowledge of some of the Kafka components which are required inside this system design. So we need to understand, suppose we have a producer again, producer, and it communicates to a broker. You can call this a broker or a Kafka cluster server, because they are different, but still these are like related terms again. Now there is something which is a consumer. Now it will add it to the queue. Now what will happen inside the Kafka? There is something which is a topics, right? So if we just use the Kafka normally, so if we just use the messaging queues normally, suppose if we use the rabbit time queue for that, so there is no topics for that. Instead, what happens is you just directly push inside the queue, right? Suppose we have multiple services here, right? We have the service that could be service 1, 2, 3, 4. So S1 call could also be there. S2 call would also be there inside the same queue. S3 call would also be there inside the same queue. It means you have the connections as well, you have the post service as well, you have the messaging service as well, you have the job updates, and you have everything inside the same queue, right? So this is also like you can do one thing. You can when you extract the item from the queue, you can have a type check for that. But still, instead of having the type check, we can also create a separate queue, right? For each topic we can have a separate queue. So instead, what we gonna use here is, for each topic, right? Give me a second. For each topics that we have the connections, we have the post, we have the messaging, and we have the jobs. For each thing we have a separate queue. The queue can have the topic of the connection, right? We have the items inside the queue. Queue can have for the post, we have a separate queue for the post. We have the separate queue for the messaging. We have separate queue for the jobs, right? This is something very important inside the Kafka, that you can use a topic for each and everything. It will help you to scale better, right? Scale better. My handwriting has got very bad with this pencil, right? But still, yeah, we have all these things which are running with that. That's how we can use topics for that. And again, we have something which is a partitions. Partitions is something inside the Kafka is, suppose we have the topic of the connections. So suppose you have 1 million connection request. Suppose the LinkedIn handles 1 billion connection request. So there might be 1 million elements inside the same queue, right? So instead of just moving on with that like 1 million items inside the queues, we can break down the queues inside multiple partitions. Like how we can do that within the SQL as well, the MongoDB as well. We can create a partition. So it means we can create partition 0, partition 1. We can store half of the queues here, half of the queues here. So it is also breaking down into multiple things. We are just breaking down within the trees. Instead of one single tree, we are breaking down into multiple things, right? This is something we are doing with the Kafka, right? We have two queues for that. We can also have multiple partitions. Whatever do you want? You want 5 partitions, you can do that, right? So this is something that we can do better. And there's another thing that happens in the Kafka is there is a commit offsets, right? So commit offsets is something. So whenever there is some item within the queue, suppose we have this item has been completed, right? Suppose this item has been completed, it is done. So Kafka, what happens? So consumer will move on. It will add this inside the commit offsets. It will commit this offset. It means now it won't start directly from here. It will start from here, from this queue. Then once it will commit that, like this, once it will commit that, it will move on to the third element with that. It will directly start with this. So this is something which is the commit offset with the Kafka, right? So now we'll be only discussing these 3 things over there. But if you want a complete dedicated Kafka tutorial, just ping me inside the comment. I will be like very interested to do that. Now Let's get back to the application, right? We have this notification design, this system design version 2. Now inside that you can see this will be the API calls. These are the API calls. But now after that, we'll be having the consumers ready to take over, right? There will be the consumer 1, there will be the consumer 2, there will be the consumer 3, there will be the consumer 4. And I think we can remove the final one because it might not be required. So there are 4 consumers which are running. It will like add inside the broker. So there will be the broker, right? There will be the broker. So it will add inside the queues. With that, all of the notifications will be added inside the queues for the multiple for the multiple topics 1, 2, 3, 4, and consumers will directly communicate with this. And after that, the consumers will handle communicating with the third party services, right? We can use the same third party services again. That could be APN, FCM, Firebase Cloud Messaging, Send Grid will be moving on with Twilio. We'll be moving on with another thing that could be web sockets, or that could be the web push as well. That could be the web. Now they will communicate with these channels and then we will work with that. Now the consumers have the job to move on to process that particular notification from the queue, and the notification data will include something that is like a send through the mail, send from or to, or send to the mobile number using the Twilio WebSockets integration. There might be a separate socket IO service for that, a WebSocket service that you can communicate, right? Now, again, there are some flaws within this system as well. If we move on, within this system as well, there are some flaws that we need to take. We can take an example from that. So again, if we discuss about the flaws, there is multiple services. All of the services are communicating with the notification service, right? They are communicating with that. But again, this is not the SPOF proof. Again, we have the single server running on with that. We have a separate DB, we have the separate caching, but still we have single server running on with that. Instead, we have implemented a very excellent, I won't say the excellent, but very great thing, which is the message queues, right? This is the queues, but still we have SPOF. Another thing that we can move on, we can just store the problems here. We have the SPOF again, which is the single point of failure. Second thing that we have to tackle is, if we just check, we have one single services which is handling the notification. We have one single service which is handling. Again, either we can create multiple instances, because for the 2K request something, now you can see it will handle at least 2K. And you know why? Because now it is not processing the complete thing. It is just creating a record. It is sending us back that notification has started processing. It can scale good. Like now almost around 3K requests will be there. Not even 2K. We can use 3K requests per second or something. It will work perfectly fine. But still after that we can create multiple instances. Alright. So we can have no multiple instances. Third thing is data loss, right? This is very important, which is a data loss. We have to take care. So we should not have a data loss. Even we are storing inside the DB, but what if the notification did not send, right? What if we move on with that? We move on to a particular queue. It moves on to first consumer send via the APN. What if it failed at this step, right? So we have to check something for the data loss. So we should use something which is a retry mechanism. We have to use that so that we can work perfectly with that. Final thing that we have to use is, we have to use another thing that is like DLQ, which is related to the retry. It means after 3 retries, if the retries are greater than 3, right? We should move the notification inside the DL queue. It means the det letter queue. What will happen there is, then after the notification is sent to the DL queue, now it is available for the manual handling. Now there is no automation for that. We have the manual handling for that, right? So again, we have the five. Again, as we discussed inside the message queues, we have multiple partitions. We can use partitions as well, right? We can use the partitions. So keeping these things in mind, I have created the final design, right? So final design won't be like this because this was for the rough design. These are the rough designs. Final design, I'm going to show you within the screen. It will just take a second. So these are for the rough designs because we have to use a lot of things here. Final design are going to be coming on into the screen now. So this is gonna be the final design for the notification system. This time we took the examples for the connections, messagings, post, jobs, and the like or comment regarding any of the post or regarding any of your job application or something. Now what happens is, now you're gonna redirect, like now you're gonna talk to the Nginx service. That could be the load balancer. Now we have four producers for the notification, right? This time we have the four producers of the notification system, and they're gonna communicate with the database or they're gonna communicate with the Redis. So all four services works the same way because now we have the four instances for each of them, and they are going to communicate with the DB and the cache services. And then when any of the requests comes in inside these when any of the requests when any of the requests comes in either from the connection, messaging, or the post, they're gonna move on. They're gonna create the separate queue for that if the queue does not exist, or they're gonna enqueue inside the specific form, right? Inside the specific topic. Like for the connections, we have the queues, like this is the element that they can insert. This is the element that the partitions for the specific queues can use, right? We have the messaging, we have the two consumers, we have the consumer application running here that have two partitions. One handles the P0, one handles the P1. Again, for the post, it handles, there are two applications for the consumer. One handles the P0, one handles the P1. Same happens for the jobs, and same happens for the likes or comments notification queues, right? We have the insertion and deletion inside the queues as well. And then the consumers are gonna talk with the API providers, like that could be the Firebase, SendGrid, Twilio, WebSockets, or the Web Push, right? So this is the final design for us, right? Now there is something which is a retry mechanism, right? There's a retry thing here as well. So if the consumer sends the request to these providers, to one of these providers, and suppose it failed, so it is going to retry. So that request is going to be back to the notification producer. That could be via the HTTP call, or that could be, so Kafka has something, it will retry it on its own. So after 3 retries, we can pull that to the DL queue, which is a det letter queue, right? So we have the retry mechanism. We have the producer again. Producer will again encode the message within the queue. Then we have again the partition for that. Then we move ahead with this logic, right? So this is the final design for us, and this is the final design for you as well. You can take a snapshot, whatever you want, you can do that. Apart from that, I've created the steps as well to work with this, right? So any of these 5 services sends data for creating the notification. The notification producers are behind the Nginx load balancer with 4 instances running with that. And this is the data that they will send along with that. It could be the notification, that could be the to form, from type, that could be the connection, or state that we can send is accepted or rejected or something else, right? And apart from that, now we have the producers which store data inside the DB. They can store the data inside the DB, like the notification ID could be there, its state could be there, and keep the memory inside the Redis as well for the faster lookups and operations. Producer then pushes the notifications in one of the queues, right? They will send in one of the queues, and then the consumers picks up the items from the queue. It will process that, sends to the any of the provider to keep its state, right? And they will also update the DB as well to keep the state. They can update directly the cache. It will be more helpful to keep its state. Like if suppose inside the DB, the state was initially like it is processing. Now the consumer, once it moves on, it processes that. The state could be the processing, or if it sends to any of the provider, it means the notification has been sent. So that notification state is going to be updated within that. Now, if the notification is successfully sent, we again keep the state to sent or delivered. And by chance, if the notification failed to send, we update the state with the retry count. Finally, it will be retried 3 times, and therefore thereafter it will be added to the DL queue for the manual handling. So Kafka will automatically handle that, right? Finally, the notification will be sent to the appropriate device, right? So this is something that is perfectly scalable. It is not a perfect system, but still it is perfectly scalable, right? So that's it for the notification system design for us. It was a great lecture as well. You may have learned a lot of things like the Kafka, the all the providers, the consumers, partitions. So you might learn a lot of things. So inside your next interview, you can ace your next interview as well, because these things are required. So that's it for this video. If you learned few things, then you can just write a comment inside this video that we learned that. Or if you want some more designs, system designs, you can just comment it out for any of the design. We will keep that in our record, right? So that's it for this. Let's move on to the next lectures, because we won't be stopping here. We have to complete the implementation as well, right? So that's why we have to keep this up and running, and the next couple of lectures could be we'll be implementing these designs as well. So that's it. Hope you learned some new thing, and thanks for watching this video.